Oh, literally just woke up. But I need this done. I need to do this. I should have done this yesterday. But if you are just joining us today, my name is Zach. I do things in SolidWorks. And I take those things into the real world. Lots of what I do in SolidWorks has to do with cars. And today we will be speedrunning a bracket to hold one of these cheap, vintage-looking, sinkled-in radios under the dash of a 1948 Chevy pickup truck that I am helping wire up. So we don't have time for much more of an introduction, so let's just jump right into it. We're gonna go ahead and start a new file. We're only gonna need one file for this because the bracket will be a single piece. The idea that I've got, it's one of those things where you've been designing it in your head the entire time that you don't have access to the computer, working through all the different ways you're going to model it up. So one of the things that I thought about is these construction lines. We're going to use this for the width of the radio. We're going to do all of our design work with one of these cork-backed metal rulers, which are invaluable. I love these things. And a pair of cheap calipers. So, on the width of the radio, we're looking at 7 inches. Pretty dead on. Dope. And for the width of the flange, let's go 3/16. Then for the length of the bracket, it doesn't have to be very big because this radio is tiny. Inch and a quarter. Let's beef that up. This is going to be under the dash. Somebody could bump it with their knee. Wouldn't be a happy day if your radio broke off every time you got in the truck. You know what I'm also realizing is that these can be non-construction lines, so we can use them for the extrude feature. Oh, and in this sketch, we can also add our mounting slots. So all I know is that there's two screws under the dash next to each other. But I don't know their spacing. I don't know what size screw they are. Could have taken the minimal amount of measurements to figure that out. We want 3 of these. Give us some adjustability. Watch this. we're going to set the spacing equal to the distance to the edge. You have to click the equal before you can click the construction line, or it gets angry. What is that thickness? An 1/8. That's fine. This is really as simple as it gets. We're not getting fancy with this. We do not have the time. So the entire flange should be... We're gonna make it even with this top lip here. We're going to use that same sketch. Just grab these two things. We're going to do from this surface, and then yo dog. That's what I'm talking about right there. And then on the side here is where it starts to get a bit interesting. We're just going to use circles for this because I do not have the time. So there's one over here, one over here, and one over here. Just gonna set them all equal to each other. Okay, now we can start to dimension. I do not know how or why the gain keeps getting turned up on my microphone. I think it's every time I brush past it, I spin that little wheel. This one will be 1 inch. So it's 1.5 inches. So it's probably one of these. Okay, now the distance between them, that's going to be kind of interesting to measure. I've made a critical error. All of these dimensions are backwards. Well, to my original reference. .78 is not a real measurement. Not that I can tell. Go 0.1 off the front edge here. That doesn't seem right. Okay. Yeah, that just doesn't seem... No, it does seem right, actually. Because this edge, this hole is really close to the edge. In that instance, though, I don't like the wall thickness there. So we're going to just... The bracket will shift. Well, we're just going to draw a line from the two furthermost out holes. We're going to select the midpoint of that. We're going to select the origin. We're going to make them vertically concentric with each other. Okay. And that gives us our mounting holes. Now it's time. I think those are the only critical dimensions. I think our part is essentially done at this point. We are just going to go through, add some pretties. So when you do vertical prints like this, it's a good idea to add a fillet here. You can't add a very big fillet. But it gives it a little bit more room. What I'd really like to do is print this at an angle. But then I'd have to support all of this. This is too thick. What the heck is 0.3? Okay, and then for it to print well, you don't want to start with a tangent off of the bed, straight off the bed. Otherwise, you'll get overhangs. You start at 0 angles, and you have to work your way up to 15 degrees before, or 30 even, before you get clean overhangs. So we're gonna start with a chamfer, which we know will print right away. Very nice. Then we're gonna add a fillet to make it pretty. Because if you guys don't know by now, I am a form first kind of designer. It has to function, but I'm gonna make it look good. Okay, she ain't bad at this point, but let's go ahead and see about... Nah, we don't have time for that. think that's all she wrote, folks. We get a couple different options. This is not right. Yeah. So we have the ability to move it forward or backward by 3/8 of an inch at a time. I don't think that's strictly necessary. So we're gonna get rid of this. I don't remember how to edit a linear pattern of a sketch, so sorry. Alright. That's good. That looks much better. Okay. That's it. Oh, we haven't even saved this part once. That's how quickly we are working here. Okay, so we've got our part saved. We need to save it as a 3MF. And we're gonna switch windows. Give me 1 second here. Okay, we got bamboo open. We're gonna pull our part in. We're gonna orient to this face. White. We don't want white. Dude's truck is purple. We're gonna go black. And then we always use gyroid when you can. We're gonna do 25%. We'll slice it. Let's take a look. Pretty decent. Alright. We're gonna send this to the printer. And I'm going to go load the film.
Never wanna try to battle rap. Snap, crackle, pop, mind fried to a crisp, make an MC into a wide-eyed lunatic.
Okay, so I forgot that I have ASA, which is the perfect material for this part, loaded up. So we're gonna have to we're making this part out of our ASA. Boom. We want all the same strength characteristics we just did. We need to load the ASA. Something I hate about Bamboo Studio is the load and unload sequence. It just takes a million years. It's actually much quicker than it used to be. But, anyway. Okay, while we're waiting for that, let's send the part. What am I gonna get for breakfast? I'm thinking everything bagel. Everything bagel sounds pretty dope today.
Yo, microphone check, make it a microphone check. Give it a microphone, I make it a microphone dead. Don't step to me, newbie, I could truly be moody. I could have played the fucking Grinch in the movies. I've been a part-time shadow cat, part-time. That is not a guy that I would ever want to try to battle rap. Snap, crackle, pop, mind fried to a crisp. Make an MC into a wide-eyed lunatic.
Okay, so we are extruding filament, but I always like to pretend that it didn't work a couple times to have the machine push out a little bit extra. I know it does a purge cycle, but maybe that's just a carryover from when I was running my home-built machine. I don't feel like it's enough. Filament extruded, continue. Why is my camera preview not working here? Alright, so we're loaded on there. Go to our micro SD card, our models. We're gonna print. Why can I not see the printer preview? Let's try reloading Bamboo Studio. So, that's pretty much it for today. I was able to create that bracket in about 20 minutes with some poking around. Even with some poking around with the printer, we're under half an hour. And now I have to go because I try to get everything I can do done in the weekend. So I'm letting Bamboo install whatever update they wanted to, and then I have to go build a lawnmower for my grandma, an electric lawnmower. Which reminds me, if you stick around here long enough, and if I stay motivated long enough, we are going to build a GPS controlled lawnmower. And I have everything on the way for that project, and another a project I mentioned last time, which is a scaled down version of the antenna that I work on. So we're going to build about this high satellite receiver antenna that tracks celestial objects with a little interface on an app. So you'll select, I want the antenna to point at the moon. It'll get your GPS location, your it has a compass, so it'll be able to orient itself, and then it'll track those objects. So what I would really like to do, because it's a lot more interesting than stars and stuff, I'd really like for it to be able to track LEOs, which are low Earth orbiters. Things like the International Space Station, and that's the only one I know, actually. I think Starlink are all LEOs, but I want my little antenna to be in stow position, then get a command that the satellite's coming up, and it'll go and then it'll orient itself and track it across the sky, and then put itself back in stow position. That is what I'm after. So I've got all the parts coming for that, because I want to do career day at my kid's school, and bring that device. Okay, we got Bamboo reloaded up here. Man, there we go. I'm just dumb. Okay, what's happening? Heat bed is heating. So we are doing ASA, which is a lot more picky of a material, and so we'll give that a second to continue reaching 100 degrees. 76. This is gonna be a while. You don't need to watch this. What I will do is I'm gonna edit this together into a YouTube short, and I will add the time lapse. I'll add the time lapse of this print to that short. So if you're curious, and then I'll add a update on whether or not the part fit, which is always good to find out. So thanks for watching. My name is Zach. You've been watching a CAD snack, which is just a little snippet of design work and 3D printing. And if you stay tuned, you'll get to follow up on these projects. I'm streaming as often as I can or want to. I already do all this work, so might as well throw it up on the internet for someone else to follow along. Thanks for watching. We'll see you next time.